Hello,
how's
Adam.
it going? Yeah, how's it going?
All right, I think. Yeah, are you okay?
Yeah, more or less.
You're here. This is BlaknBlu, and you've been here before.
I've never been to this show before.
You haven't?
No.
We've obviously seen you at Schneider
at
Superbooth
a couple of times. Yeah.
But, welcome to Machina Bristronica.
It's very exciting.
Yes, and it's always a pleasure seeing what you've been up to. We've seen your
the big boys before.
The big boys, these alphas, which are absolutely lovely.
So yeah, that's a big VCA mixer thingy, and this is a filter bank.
This is the Foxtrot, isn't
quad
it?
Filter,
Yeah, filter VCA.
Yeah,
essentially.
Yeah,
4 off
of each. Yes.
And as I understand it, you've got something new you're showing here today, which
I
think is this one called Doug.
Doug is new. We'll come to Doug in a minute.
Yeah.
We've got a sort of traditional subtractive synthesis stereo voice, if you like.
Yes.
And Oscar DSF is a complex oscillator that sounds like FM but isn't.
Okay.
There's a really nice some stuff on the YouTube.
All of these are available at the moment.
All these are currently available. Yeah, everything's available.
Foxtrot Duo, Alpha Duo, and it's the Tria. That's one I can never remember. Tria, sorry. Tria. Yeah.
So, we'll start with that one if you like.
Okay.
So Tria is a 3-mode oscillator. In its simplest mode, let's just open this filter up so that we can hear it. Probably without resonance would be good.
That was it was quite musical.
In the green mode, it is a fairly straightforward oscillator. So you've got variable waveforms, pulse width mod, all the usual stuff. There is 3.0 FM. That's hard sync on one of these auxiliary inputs. There are 2 sub-oscillators. So there's a sub and a sub-sub.
Juicy.
Let's just start that again without them so you can hear. That's just a sawtooth, 1 sub and another sub. So they can get quite juicy.
Nice.
Second mode is a kind of a swarm oscillator, super saw kind of thing.
Mm-hmm.
So again, similar idea. We've got plenty of oscillators. We can choose how many oscillators we have, from 1 up to lots. I can't remember how many. Again, waveforms are variable from super saw, super square with pulse width mod, which is quite nice for some sync sounds.
Yeah.
There's super triangle if you want, but that's kind of super boring. There is with that a sub as well. For extra beefiness. So that's without the sub. And then that's with the sub.
Yeah.
Pretty much all there is to say.
You've got these 3 modes.
Yes, so that's green mode is the standard oscillator.
That's right, sorry.
Purple mode is the swarm oscillator. And then orange mode is a chord oscillator. So it plays chords.
Yeah.
You can select which chord you play. There are 20 different chords,
which I guess you can CV.
And so you can CV that. So here I've got coming out of the Oxy, I've got pitch and which chord on the same thing. So if we just play that sequence, we've got fairly horrible envelope. That's,
nice, and it's all in tune.
And they're all in tune. So it's useful if you just want polyphonic pads, and you don't, and you've got to, you need to sequence them essentially.
Yeah.
But it gives you the ability to have some kind of polyphonic pad in a Euro rack environment.
Lovely.
Very hard to see.
At a flick of a switch.
At the flick of a
which
switch.
is pretty handy, actually. So if you are playing live with this, that's quite a nice live performance tool, just be able to switch between like chords or your bass line or whatever.
Sure.
That's nice.
Let's go back to the normal oscillator and turn this keyboard thing back on. For that is quite beefy, isn't it? Filter.
Yeah.
3 different kinds of filter. You've got a Moog style ladder filter,
Okay.
a Korg style MS-20 style filter, and a filter like the Oberheim SEM.
And you can just flick through those different ones again.
Okay.
Yeah.
Moog ladder filter,
Yeah.
Korg MS-20 style filter, and an Oberheim SEM style filter.
Lovely.
They're all sweepable from bandpass. Let's play a note. They're all sweepable from bandpass through low pass to high pass, and that's available under CV control, of course, as well.
Cool.
So you've got kind of got that fat Moog sound, sort of wet. The Korg, of course, is a bit nuts, particularly if you turn the resonance up, it starts to scream in that
in
that Korgy kind of a way.
Yeah.
And then the Oberheim is just lovely and smooth and delicious. It's the only one that won't it'll whistle, but it won't self-oscillate.
So look, there's something about the sound of these. When I first heard them, I don't know if it's just the way that you're obviously making them, but they've got a real quality, like the sound, if you don't mind me saying that.
Well, thank you
they're
very
like
much.
big and juicy.
Yeah.
And the way that and the filter pairs together, I don't know. I mean, they just sound really, really nice. And so
thank you very much.
You probably don't want to give away your secrets here and what you're doing, but
well, a lot of that really comes from the characteristic of the original classic filters. They were great.
Yeah.
We didn't pick those filters for no reason.
Yeah.
They are great sounding.
So I guess you go look at the schematics, see what's going on with them, and essentially just build from there. And
exactly, yeah.
But you can tweak them, make
It's worth pointing out these are digital.
Right.
Okay.
Yeah.
So, but they're not traditional virtual analog models. Without getting too nerdy, what we basically do is we simulate the components in the circuit rather than a virtual analog model, which is kind of an equation you make up that represents the whole circuit.
Okay.
So that means that those non-linearities, particularly in something like the Moog ladder filter, which is just ridiculously non-linear.
Right.
So it's 4 non-linear circuits in a row that just gets nuts.
Okay.
And we can represent those non-linearities really well, and that's really why it sounds rich. And that's why the Moog sound. It's a terrible design, you could say.
Is it?
But no, it's genius.
You're speaking to somebody here who just plugs it in and goes, that sounds nice.
No, it is genius, and it was amazing. It is still an amazing filter.
Yeah.
But it's not a linear, beautiful thing.
Okay.
It's very non-linear, and that's why it sounds so delicious.
Right.
And so we model those really, really closely, basically.
Yeah, well, they sound great.
And then the final thing we have is, let's go back to a Moog-alike, is a VCA. It can be 4 quadrants, so it can act as a ring modulator as well. But perhaps the most interesting thing is that we've got a couple of nice drive modes. And they, again, work nicely with the non-linear filter elements. And
is that driving in to it, or
that
is that
drives
driving
into it, and then the VCA itself models these drive modes. So there's a valve model, which is quite a sort of it's quite so the positive part of the waveform and the negative part of the waveform are treated differently, and it's quite a soft fuzz. And then the second model is a much harder kind of diode clip guitar fuzz pedal kind of sound.
Right, I've never thought about the way you can actually treat the top and the bottom of a wave differently to get different harmonic. Right.
Valves naturally kind of do that when you overdrive them. Their bias point changes, and it changes the way that the waveform's treated. And again, that's one of the reasons why they sound so nice.
Right.
It's all to do with second harmonic.
Yeah. It's great. I get to learn about all the things that I've been using most of my life at events like this. So I appreciate the input.
Cool.
Very cool. Okay.
Yeah. And that's about it, really, for those three.
Yeah. So you've got a lovely voice there, basically. Your oscillator, filter, VCA, variations of drive input into the VCA as well.
And of course they're stereo. So one thing you can do if we go back to here is we can detune the second oscillator and get that nice sort of slightly chorusy.
Yeah.
A bit hard to hear on headphones. But, or you can even use it to, if you one of the things you can do is knock this into mono, and then just use that as a separate power chords, baby. Add some distortion. Why not? Give the guitarist a run for his money.
Speaking my language now.
The other thing worth noting is that you can even overdrive the filter as well. So there's a 12 dB gain switch on the way into the filter. For even more, let's turn that one off so we can listen to it on its own. So that's without the drive, and then you can overdrive the filter and get some quite nice sort of grungy. Works very nicely with the Korg as well, actually. So let's go balls out.
Yeah.
I wonder if I can make this thing arpeggiate. It's new to me, and I don't know how it works. Turn the arpeggiator on.
No pressure.
No pressure. How does that work? I have to press play.
All right. Very Daft Punky.
Something like that.
Awesome.
Terrible,
Love it. Very
right.
sort of Daft Punky soundy there with the squelching and.
Yeah.
Yeah.
I'm all for the distortion.
So tell us about Doug.
So Doug, okay. Doug is a combined. Actually, if you can, come and look at this
And
one.
this one, yeah.
Yeah. So Doug is a combined envelope generator and LFO. As an LFO, you've got square wave, triangle or sine. There are some option links on the back, and that allows you to swap it to sine. But this switch panel actually can also break out those option links. So the bottom switch there, which will switch between triangle and sine. You've got both kinds of sawtooth, so rising and then falling, and falling and then rising.
Okay.
Pew pew and whoop whoop.
And they cycle round, I presume.
Yes, yeah.
As well.
So this is an LFO,
you've got
so it's LFOing at the moment.
Right. Okay. But take it out of that mode and it just becomes a one-shot envelope.
So you can actually one-shot the LFO.
Oh, right. Okay.
So that will generate one cycle, perhaps of a triangle, or one cycle of a sine.
Yeah.
You can also one way I use it a lot is every time you trigger it, you'll get a new sample and hold value.
Oh, okay.
So it's really useful if you just want a new random voltage each time a clock goes off.
Okay.
So you can one-shot the LFO or have it looping. So you've got, what was I saying, square, triangle or sine, both kinds of saw, sample and hold, and a white noise output. You can mix all of those together. So you've got two identical outputs, and they're a mix of all of those waveforms. So you can get some really interesting, complex modulation waveforms.
Nice.
As an envelope generator, we've got attack, decay, sustain, and release as usual.
Yeah.
But there's also a wait phase between the gate starting and the attack starting.
Okay.
So if you think of like auto-generated auto vibrato, where you're delaying the vibrato coming in.
Yeah.
Again, it's loopable, so those it really comes into its own when you loop things as well. There's also another phase between the after the attack and before the decay. You can hold that maximum level.
Okay.
So you've got 6 phases. You can wait after the gate, attack, hold, decay, sustain, and then release.
Interesting.
And that's loopable as well.
Wow, okay. So you can really get some really interesting
So you get
shapes
some quite
out of this.
groovy
Yeah.
modulations out of it as well.
Yeah.
It can be unipolar or bipolar.
Okay.
So 0 to 10 volts for traditional envelopes, or plus or minus 5 volts for modulation.
Yeah.
You know. There's gate and trigger. The LFO is retriggerable, so you can always start the LFO at the same place.
I'm just trying to think how this would be synchronized. Would you just use it with the gating?
So I just put the same gate that I'm using into the envelope, into the LFO. So every time you play a note, it starts the LFO in the same place.
Yeah.
And it's very cheap.
Okay. Is it available now?
It's available now, in stock.
And how much are we paying for this beauty?
Including VAT in the UK, it's £95. So that's
That is-
79 quid and change.
That
plus
is
your
cheap.
local taxes.
For such a complex kind of envelope waveform generator, if you like.
Yeah. It's a little bit more. So that's dug on its own.
Yeah.
And then the switch panel is optional. You can buy them.
This 2U.
Yeah, just a little 2U.
What does that give us then? So
it gives you that ability to swap between triangle and sine.
yeah.
You can make the envelopes either log as usual or linear.
Yeah.
And then there's some interesting things here. Normally, if you think about a normal envelope, if you've got a long release and you re-trigger it, the attack starts from wherever the release voltage was at.
Yeah.
But you can actually force it to dump back to 0 and always start the attack back at 0.
Yeah.
So it just gives you a little extra percussiveness to your attack if you've got long releases, but you still want to keep re-triggering.
Fantastic.
So yeah, nice and cheap, cheerful. The idea is that you just put a load of them in your rack, and every time you need either an LFO or an envelope, you've always got one available.
Fantastic. Well, it's great to see the BlaknBlu system, if you like, growing. Every time we see it, there's something new.
Good. We'll try and keep it up.
Yeah, absolutely, and keep up the quality of what you're doing as well. It's really good. The fact that you can get such complex waveforms out of such a small module. A lot of my music I'm just using complex envelope generation and things like that, which often means that I've got to have multiple modules with different LFOs, different envelopes, sum them together somehow, add and subtract, and that takes up a lot of HP.
Yeah.
What's this again? 6
HP.
6 HP. Yeah. Fantastic.
Yeah.
Well
and
done.
the mixing is quite interesting. That if you just have a single waveform, it will be plus or minus 5 volts.
Yeah.
It's not a summing mix. So when you add the next waveform in, the entire waveform stays at plus or minus 5 volts.
Okay, right.
So you're not summing and having to reset the amount of modulation you've got. It stays in that voltage range.
Handy.
Hopefully.
Great stuff. Well, thank you so much.
Well, thank you for stopping by. Why is that so hard to say?
Thanks very much.
No
Cheers,
worries.
mate.
Thanks a lot.
Bye.